Hi everyone, welcome to week 9 of your college algebra course. We are almost done. This week we're going to be covering chapter 11. But before I get into this week's material, I do want to remind you that next week, your week 10, you have to have everything completed by Thursday of that week. So not this Thursday, but the following Thursday. So Thursday the 18th is when everything has to be completed. So that includes any missing work as well as your final exam. So if you are getting behind or if you have gotten behind, make sure that you work on getting those things turned in as soon as possible. Because as of the 18th, I won't be able to take anything else. So it's really important that you get caught up and stay caught up. Okay, so let's take a look at Chapter 11. Chapter 11 is all about solving quadratic equations and functions. When we talk about a quadratic equation, it's something that has a square in it. Okay, so if you've got something raised to the second power, that's a quadratic equation. So we're going to look at several different ways to do that. We're going to solve quadratic equations using the whole idea of square roots. So taking the square root of something, and then finding those x-intercepts of the graph. We're going to also look at solving it by completing the square and by using quadratic equations and applied problems, things like that. So let's look at some examples of what are quadratic equations. Here are some examples of quadratic equations. Notice that the one thing that they all have in common is they have something raised to the second power. So even though they're in different orders, they might have variables on both sides of the equation, we can rearrange them. That's not a problem. But ultimately, the highest degree is a second degree, so something raised to the second power. So what we typically want to do is to get that equation, that quadratic equation, into what we call standard form. Standard form is where we have the squared term first, then the term that's to the first power, then the constant, and it's set equal to 0. And so the whole idea here is if we get it into the right format, then we can solve using one of our different ways that we're going to be looking at in this particular chapter. So when we think of the square, solving these quadratic equations, some of them are going to be fairly straightforward. For example, 12m squared equals 144. We can solve that one because there is no x value. We can simply solve for x. So here's an example. X squared equals 36. We can solve for x by finding factoring and doing it that way. But we also know that the square root of both sides, if we take the square root of both sides, we're going to get x is plus or minus 6. So that's another way to look at those types of problems. So if there is no middle term, that's probably the easiest way to do those types of problems. Here's another one. X squared equals 25. So again, we know that there is going to be two square roots of that, positive and negative 5. So if they're in this type of format, in other words, if they're in this x squared equals some constant format, we can easily just take the square root of both sides. So that's called the principle of square roots. So when you see a equation in that format, you can use that particular principle in order to solve. All right. Then we have something called completing the square. So if we have something with an x squared term and an x term but no constant, we can do something called completing the square. And what that means is we're going to take that middle term and take that coefficient, so that b, and we're going to divide it by 2 and square it. And we're going to add that to both sides of the equation to make it easier to solve. So here's one example of completing the square. Okay, so here we've got one. Trying to see what they did on this one. The coefficient of the x squared term has to be 1 in order for you to be able to use completing the square. So the first thing that they did was they multiplied everything in this equation by 1/3 so that we could get that coefficient to equal 1. So that's what we did first. So that's where this first piece comes from. Then we're going to move this constant to the other side of the equation. So subtracting 1/3 from both sides, so we put the 1/3 on the other side. Then we can go ahead and complete the square. Now remember, completing the square means that we take half and then square it. So that's where the 49/36 comes from. This one's a pretty messy one. So if you had trouble, following along with that one, don't worry about it, because there are a lot easier ways to do these types of problems. So this particular one wasn't probably the best example that they could have given us for completing the square, but just know that, the first step is always to get that coefficient equal to 1 for the x squared, and then you're going to take half of the b and square it, okay? And then as you go through, you're going to find some other things. Specifically, the quadratic formula is going to be your kind of go-to thing. Like I said, that one that we just had for completing the square was kind of a difficult one. Using the quadratic formula is going to be the easier way to complete that type of problem with some of those messier numbers. Then we're going to look specifically at just some things to predict what the graph might look like. So if we look at just this piece of the pie, so to speak, this piece underneath the radical, that's called the discriminant. And so as you go through this chapter, you're going to see that looking at just that discriminant and its qualities is going to kind of tell you something about these graphs as well. If at any time you have questions as you go through all these slides this week, please don't hesitate to reach out to me. You can call, email, or text anytime. My number is 618-792-2293. Have a great week.